Welcome back to our YouTube channel. I'm Joseph Jobs Kaira. You can get me by this email, or you can get me on this contact by call or WhatsApp. I teach chemistry and mathematics at both A level and ordinary level. Don't forget at the end or before even ending this video to subscribe. Don't forget to subscribe to this YouTube channel for more lessons of this kind. Today, I want you, dear students, to start with me the topic called electrolysis. Electrolysis is not a hard topic as many people confuse it. It comes from two words. Electro comes from electricity. Electricity. Then this word lysis means to break down. To break down. If you don't call it break down, you can call it to decompose. So electrolysis shouldn't be a confusing term. That implies that we are using electricity to break down. What do we break down? We break down compounds, which compounds we call electrolytes. We shall later see what an electrolyte is. So please don't be confused by the term electrolysis. Don't forget to subscribe to this channel for more of the videos of this kind. Let me introduce you to this topic by first of all having something I'm calling an introduction. Remember, this topic I will be looking at specifically content for all level. Now, one of the many forms of energy we know, one of the many sources of energy, or one of the many forms of energy is electricity. As I speak now, there are very many bulbs lighting in the city or in your home or anywhere around you, and they are lighting because of electricity. It's a fantastic and a very common source of energy. Now, this electricity is one of the many forms of energy that is conducted. So electricity is conducted. What conducts the electricity is conducted by materials that we call, materials that conduct electricity are called, somebody is thinking about it, those materials are called conductors. So conductors are substances that conduct electricity. So any substance that does conduct electricity is a conductor. And these conductors are mainly metals. Conductors are mainly what? Yes, Jonathan is thinking about it at his phone there. I'm seeing him. These conductors are mainly metals. Metals such as, which metals are very good conductors? Yes, that one, copper. It's a very good conductor. Another one is aluminium. So copper is a very good conductor to the extent that is used in making electric wires, copper wires. You have seen that brown, those brown thin wires inside the red capping. You see something red covering them, or sometimes the wires are black. They are black wires, but inside the black wires, are those inside the black rubber tubing are those brown wires. Those brown wires are made up of copper. Aluminium, you have seen the electric wires moving all over trees. Should I call them trees? No, poles that are dried up. So those wires are normally gray. Most of them are made of aluminium. We have so many other metals that are very good conductors, but the most common ones are copper and aluminium. Yes, hoping that is at the back of your mind. I can now proceed. Not only metals conduct electricity, no one should lie to you that it's only metals that conduct electricity. It's not only metals that conduct electricity. We have so many other substances that conduct electricity. Some other substances in solution or molten form conduct electricity. So these substances, when in a solution, what do we mean by saying in a solution? We mean that when dissolved in water, some substances, when dissolved in water or in molten form, in other words, when they are heated to melt, do conduct electricity. They do conduct electricity. Now, these substances which conduct electricity when in a solution or when molten are called electrolytes. Have you got it, Janet? Yes, such substances are called electrolytes. Such substances are called electrolytes. They conduct electricity in solution or in molten forms. And when they conduct electricity, they get decomposed. So when electrolytes conduct electricity, they decompose, okay? Unlike metals, the metals do not decompose when they conduct electricity. Otherwise, if the metals were to decompose as they conduct electricity, then those electric wires you see on the poles everywhere you're moving couldn't be there. In your room, there couldn't be electric wires in case those metals, copper or aluminium or others, were decomposed by electricity. But the electrolytes, when in solution or molten form, conduct electricity and get decomposed by that electricity. Now, having had that very wonderful introduction, let us look at the definition of key terms. What key terms do we need in electrochemistry or electrolysis? The first key term is this one. Which word is this? It is the previously looked at word, the electrolyte. What is an electrolyte? Okay. An electrolyte, we have already seen, is a compound. It must be a compound. It must be what? A compound which conducts electricity. That compound conducts electricity or electric current. You can call it electric current. Conducts electric current in aqueous solution. In aqueous solution or in molten state. It must be either in aqueous. If you talk of an electrolyte, then you should talk of the aqueous state. It's a compound conducting electricity in aqueous or molten state. In aqueous or molten state, and is decomposed. and is decomposed as it does so. And is decomposed as it does so. So whatever you see me underlining is a keyword that shouldn't miss in your definition. That shouldn't miss in your definition. As it conducts the electric current in the molten or aqueous state, it must be decomposed. For example, the Frenchmen say par exemple. So for example, can we look at an example? Yes, let us look at one example. The example I'm going to look at is copper 2 chloride. Copper 2 chloride. This one in its solid form doesn't conduct electricity, but it must be a solution to qualify to be an electrolyte. So copper 2 chloride solution conducts electric current. Conducts electric current. What does it use to conduct electric current? By use of what we call free mobile ions. So this brings me to another point that I want you to understand, that electrolytes conduct electricity using free mobile ions. For example, copper 2 chloride, copper 2 chloride in solution ionizes to give us a copper 2 ion. It has ions in it. It's an ionic compound. In solution, it ionizes to give us copper 2 ions and chloride ions. And chloride ions. A chloride is a negatively charged ion. It's an anion, whereas the copper 2 ion is a cation. So it has a positive charge. And because of the valence of 2, it has 2 positive charges. The chloride ions are 2 because of this formula here. So that's the equation. Now these ions are free mobile in solution. They are free to move. Free to do what? Free to move in solution. So that's why you call them free mobile ions that do conduct electricity for electrolytes. So copper 2 chloride conducts electricity in solution. However, there are some other compounds that may not conduct electricity in solid state, but can conduct electricity when molten. Can I give you an example? Yes, I can give you an example of potassium iodide. Ki is potassium iodide. The word potassium is symbol T, SS. Most of you make mistakes by calling it TT, double T, then symbol S. That's not acceptable. So molten potassium iodide can also conduct electricity. How does it become molten? It becomes molten on heating. So molten potassium iodide conducts electricity due to free mobile potassium and iodide ions. Now, since we are using the word molten, here I don't expect anything like aqueous. It is initially solid, so when you heat it, it melts. And when it melts, these ions are in liquid form because they are molten ions, ions in molten state. There's nothing like water. You just heat the solid, the potassium iodide, to melt. So to get us the potassium ions and the iodide ions. So those are the ions that conduct electricity. So this summarizes the concept that what did I want you to pick here is that electrolytes conduct electricity using free mobile ions. Using free mobile ions. But we saw that metals are also conductors. So what conducts the electricity in metals? Metals like copper and aluminium. For them, all nonmetals, actually, there is also one nonmetal that conducts electricity. All nonmetals, like, not even like, this should be one example, or I think I should say, or nonmetal specifically, I should be specific here, or nonmetals specifically. Which nonmetal conducts electricity? You looked at it under carbon and its compounds. You looked at that allotrope of carbon, graphite. These three conduct, and some other metals conduct electricity. Can you guess what they use to conduct electricity? For them, they don't use iron, since they are not ionic. Metals are metallic. They have metallic bonds in them. Graphite, being a nonmetal, for it has very many strong covalent bonds in it. Remember that structure. If you forgot it, revisit it.